Last spring, I started working on a game that sounded almost contradictory. I wanted a strategy game where you don't command units from a bird's eye view. Instead, you play as a character inside the world. You run, collide with objects, and experience the battlefield from a third-person perspective. At the same time, you're not alone. You command a group of NPCs, but you don't micromanage every step they take. You give them orders, and they figure out how to accomplish them on their own. In most strategy games, units don't really make decisions. You tell a unit exactly which tree to chop, exactly which rock to mine, and exactly where to stand. They are just executing instructions. I wanted to flip that idea around. Instead of guiding NPCs every step, I wanted to give it a much more abstract commands. For example, bring me a stone. At that point, the NPC has to figure out what that actually means. Which stone should it choose? Is the closest one really the fastest to reach? What if another NPC is already heading for it? And what if halfway there, it suddenly runs into 5 enemy units? Should it keep following the order, or should it abandon the task, retreat, and try again later? Those kind of situations emerge naturally from a cooperative planning algorithm that continuously re-evaluates the world and adapts every NPC's plan as conditions change. And because I also wanted to experience the game from a third-person perspective, every character, including the player, had to exist inside the same physical simulation. Characters have real collision volumes, so they physically occupy space instead of ghosting through one another. Because you control your own character directly, you actually feel the physical presence. Those ideas shaped majority of the systems that came afterwards. But getting all of that working consistently meant solving one difficult engineering problem after another. Making everything work turned out to be much harder than it sounds. Most games solve navigation in a decentralized way. Each NPC plans its own path independently, and when two characters get in each other's way, they resolve the conflict locally. For example, there is a popular algorithm called reciprocal velocity obstacles, which if there are two NPCs that are about to collide, just changes their directions a little bit to avoid that. For many games, that's perfectly fine, but it also leads to familiar situations where two characters meet in a narrow corridor, hesitate, step aside, block each other again, and sometimes end up completely stuck. In a traditional strategy game, that's usually just an annoyance. You can instantly jump across the map, select a unit, and issue another command. In my game, that wasn't an option. You are physically inside the world. If one of your NPCs gets stuck somewhere on the other side of the map, you can't magically teleport over to rescue it. The algorithm has to recover on its own. That requirement pushed me toward a very different approach. At its core, my planner is based on an algorithm called Safe Interval Path Planning, the basic idea of which is to evaluate searches in order and treat paths of already processed units as dynamically emerging obstacles. On top of that, I added path smoothing, and more importantly, a dynamic reprioritization system. NPCs don't all search with the same priority. Their planning priority changes depending on what they are doing, allowing the whole group to coordinate, instead of each character stubbornly insisting on its own path. It took a long time to get right, but that algorithm became the foundation of the entire project. By summer, I had the first real prototype. NPCs could carry stones across the map while avoiding one another. Every unit had a single hand slot, in which they could carry exactly one object at a time. The map generated stones at random places. Every NPC received its own destination, and they all somehow managed to organize themselves without getting stuck. It wasn't much of a game, but it proved that the core idea actually worked. At this point, the game was completely single player, but I wanted several people to be able to play at once. So the client-server architecture emerged, and I started to move systems from client to server. First multiplayer prototype was very simple. Only playable characters existed online. Multiple people could connect to the same server, walk around and physically push against one another. Physics became completely server authoritative. I implemented interpolation for dynamic bodies to keep movement smooth over the network, and added basic cryptography to prevent packet spoofing. By the end of summer, the networking foundation was in place. After that, I moved essentially all gameplay logic onto the server. Pathfinding was now calculated server-side. The vault generated trees and stones procedurally. NPCs received their own network protocol. They could accept orders, pick up objects, drop them, and synchronize their actions across clients. By September, the game had become a true client-server simulation. Next came combat. NPCs learned to throw stones at each other. They could also throw stones at trees, knocking loose branches. Those branches became weapons that could be picked up and used in melee combat. For the first time, the vault started feeling less like a simulation and more like an actual game. Towards the end of the year, I introduced hunger. Berry bushes began spawning across the map. NPCs could harvest berries and eat them to stay alive. If they ignored food for too long, hunger gradually drained until they eventually started taking damage. Like stones and branches, berries could be carried around. Bushes themselves, however, stayed rooted in place. Food had become a limited resource. Suddenly, the map mattered. The next milestone was construction. NPCs could dig foundation holes for a hut. 10 holes in the correct shape, followed by 10 branches placed into them, produced a finished building. Inside the hut, players could craft a shovel from a branch and a stone. The shovel introduced a completely new mechanic. Instead of harvesting berry bushes, you could dig them out of the ground, carry them on the shovel, and plant them somewhere else. That meant food sources themselves became movable. The territory you controlled could literally become more fertile over time. In my mind, this was supposed to create an interesting strategic battle over territory. Ironically, one of the hardest technical problems wasn't the construction itself. It was making cooperative pathfinding work reliably inside the narrow doorway of the hut, where multiple NPCs constantly tried to pass through the same tight space. That milestone was finished in March. In April, I added reproduction. An NPC with full health and full hunger would split into 2 new NPCs. Each inherited half of the original health and hunger. This completed the economic loop. Now the recipe to overpower your opponents was as follows: control more food, produce more NPCs, control even more food. At least, that was the theory. The following months were less exciting to watch, but just as important. I fixed countless small issues. I rewrote the UI code to eliminate long-standing bugs. I optimized the cooperative pathfinding algorithm until it could comfortably handle more than 50 active NPCs without noticeable slowdowns. As usual, every optimization uncovered another engineering problem waiting to be solved.
Then, at the beginning of this August, everything finally came together. I played the first real multiplayer match with a friend. We took an hour to compete against each other and find out is the game actually fun. And that's when the weaknesses became obvious. The combat wasn't that interesting. Since every NPC moved at roughly the same speed, long chases often went nowhere. The construction system also didn't justify its cost. Building huts and crafting shovels required so much effort that the optimal strategy was usually much simpler. Just order every NPC to eat every berry on the map, grow your population, and overwhelm everything with numbers. From a gameplay perspective, that wasn't the outcome I wanted. But overall, I'm happy with where the project ended up. Most of the technical goals I set for myself are now there. The client-server architecture works. The cooperative planning algorithm scales to dozens of NPCs. At the same time, the first playtest made it clear that building interesting systems doesn't automatically produce interesting gameplay. Combat needs to be redesigned. The construction mechanics need to justify the time they ask from the player. And I'm sure there are plenty of other design problems I haven't discovered yet. So, that's where the project stands today. The technical foundation is finally in place. Now comes the part that's probably even harder: turning it into a genuinely fun strategy game.